Where's my music? Yep. Okay, so currently I have a base class that contains the head, and now it has a virtual function. Try allocate more. This was basically rewritten. So the allocate works is we read the head, and at the moment your head equals null, then head doesn't point to a free block, so we need more memory, or we need to return null because we're just out of blocks. Head points to the free list, so the free list is empty if head is null. In other words, if this fails, then we get here, meaning we reach the end of the list, and I'm trying to allocate more memory, passing a lambda that we got that will allow us to do so. But the default is that this returns false, and then we just return null pointer. Otherwise, this lambda, well, actually try allocate is defined. This function just needs to allocate more memory, put it in front of our free list, and thus after this returns, and it returns true, then mhead will point to more memory, newly allocated memory. So we can just go to the top here, get here, go to the top, read head again from the now changed mhead. And then it should be definitely non-zero because we just allocated something. But normally, of course, it is not 0. There should be something in the list from the start. So we can interpret the head as a free node. It's a block of a certain size, and it's not used, so I abuse it as if it is a free node object, which is just our singly linked list. It has an mnext pointer to the next free node, which is the beginning of the next block. This. So this gets the beginning of the next block. And then we do a COS, compare exchange weak, or a COS stands for compare and swap. Writing the value that we just found into mhead, but only if mhead is still equal to head. If that was changed, then this is going to fail, and then we are here, which means that mhead was changed. And the new value of mhead is done in head. So we just try again. Unless, of course, head becomes null, because then again we are at the end of the list and we just do the same thing as before. And if it succeeds, then we assume that the next here corresponds to, then head equals what we just replaced. But we also assume that the mnext that we read from that head is still the same thing, and that's not necessarily true because of the ABA problem. It's possible that in between here, after we read this, some other thread allocates this block and then allocates another block, and then freeze this block. That's a lot of CPU cycles, but theoretically it can happen. And then the result is that mhead is again the same value, so this head is still equal to mhead, or again equal to it, but the mnext pointer in it has been changed, and then we would write the wrong next value into mhead, so that's bad. And to avoid that, we want to encode something in mhead. Then let's say a few bits are going to repurpose as a little counter. We just increment that every time we get here. So then what the other thread is doing, so we are here, and the other thread, which is allocating 2 blocks, is going to read the same value at first. Write that to mhead, and then read well, actually, what it writes to mhead is something with a little increment, and then it reads that, gets the pointer from it, so it ignores the tag. Read that the next mnext, the next mnext, and increments the tag again on that and writes that to mhead, and then freeze something, and the freeing is equal to this one here. So that there must be tagging here as well. So we get the tag of the mhead and then increment that and write it back here. In other words, by that time that mhead becomes again equal to the one that we have in head, the tag is definitely different. So this compare exchange weak is going to fail, because this mhead now has a different tagging than what we stored. And then up and failure, this still applies, and we just read the mnext value again. Yay, which is what we needed to do. Okay, now to implement all this, I need to get my variable names in order, I think, because this mhead is now going to exist of two parts. A free node pointer and a something tagging. So it's definitely no longer a pointer, but also it cannot have cannot be a struct with a large size. So I'm going to define a type here called encoded head type. But yeah, that just has to be an integer. So not pointer div type. Probably not type. Oh, it doesn't get a color, but it's probably. Oops. We need an unsigned integer, maybe. C++ unsigned integer with the same size as a pointer. Oh, that didn't work. Let's give it a hint. So pointer div something, I think. Maybe pointer div. Pointer div. The size type have the same size and alignment as pointer div type. So pointer div type is a thing. Though this is signed, I think. I don't want to use pointer div, really. Well, I could, of course, because I'm going to cast it anyway. I would prefer something like, yeah, this one. This is the one I want. Unsigned integer pointer type. Yeah, they're all the same size. We know that. I think that's the type I want. Is that thing not defined in std namespace? I hope so. So it's probably just defined in the default header, but hey, let's look it up. What header do I need? Okay, I'm shocked. Oh wait. C standard int. What? Yeah, well, actually, that was the header that I meant, but it's a C header, you know, so it's not using std then. Oh well, it compiles. Okay, so obviously the encoded head type is must be treated as atomic. Yeah, it's atomic already, but we have to tell the compiler that we want to use it as an atomic. And I'm going to call head now not mhead, but encoded head, right? So the comment probably has to change as well. Encodes a pointer that points to the first free memory block in the free list. Yeah, but how are we going to do this encoding? I'm wondering if you cannot make a struct of this anyway. If we have a struct that wraps this, and we use that. Yeah, how in how far is that going to be something that we can work on atomically? Nah. Let's see what the AI was saying. I had a discussion about this clause that started as a suggestion of tagging, which I didn't get into because we had problems with the memory order. But that code is still there. It creates a struct. A struct that wraps the UN pointer type. And then we can get one or the other bits. But. How can you treat that as maybe just use value then? It's public and all. Yeah, probably. It is doing the compare exchange week directly on mmap-ed. And what the hell is mmap-ed? I don't think that this would even compile actually. I would say the pointer tag make will return a pointer tag. This is my make, yeah, static pointer tag. So mmap-ed is probably a pointer tag. The pointer tag does not have a compare exchange week, a member function. I suppose it could be added. Maybe it did add it and I missed it. Nope. That should have been passing value as well. Maybe you can do that instead though. I like the idea of having a... Yeah, doing it again. It's just nonsense. Nevertheless, I do like the idea of having a struct here, so... Instead of the using, we are going to have a struct, which I call... No, why not? Pointer tag. It's a combination of a pointer and a tag. And that then has an atomic. And then we're just using this. And then let's call this just encoded. The M is from years ago. Let's just switch to encoded underscore. Let's call it the head tag. Although I'm not sure I want to call it tag really, because I'm going to abstract the whole encoding stuff. That becomes a template parameter. So there's not really a tag here. Although, yeah, I mean, most bits actually must encode the pointer, of course. We definitely need a pointer. And there's only a few bits left, and we might as well call those bits tag, because what they do is just add a few more bits to the pointer to make it different. And if that is a counter or just, I don't know, whatever, you might as well call it a tag. So right now my code doesn't use the tag, but I want to start to use this, right? Let me see. I just don't like this. Let's put it here. Okay, this thing can be constructed from something that we can construct this encoded with, which is now no longer a null pointer, but we can use a null here. No, mmap-ed. Call if allocator returns runs into the end of the list, mmap-ed becomes null. It's a bit doubtful, I have to say. I'm not sure if I want to use null, and if I want to use null, then I'm not sure I want to use it for the whole encoded, for the pointer tag as a whole, or just for the pointer that it encodes. It kind of depends, and I don't know yet how that's gonna work out. Yeah, I really can't wrap my head around it, so let's just delete this comment. It's the end of the list anyway. And then we have the allocate function and the deallocate function, and then we are done, I think. This is not using mmap-ed, at least not in the header. Okay, on top of this, I know that I need to be able to get a pointer, and that pointer might as well treat it as a free pointer. That is very easy to convert to a void pointer, but now I have to return it. It's just the beginning of the block. So I want to have a free pointer here. Yeah, we can call that pointer. And for now, I'm just gonna return encoded because we don't have a tag. So the whole encoded thing is actually just a free pointer. I need a static cast here then. Can I static cast that? So reinterpret cast. Definitely feels like a reinterpret cast. Yeah, it's choosing reinterpret cast here. And also here. That makes sense. We only write to encoded with the compare and exchange, at which point I just have to pass encoded. And then a reading I can do constant, but the thing that I want to swap into it is something that must be encoded, of course. We have to prepare that in advance, and I think that maybe I want to add it here. Well, in the end, it's going to be a template something, but I think it's a non-atomic value. So we're going to have some static function, and that returns the encoded value, and I call that encoded. And well, that will return the probably a reinterpret cast the other way around of yeah, the pointer, because there's no tag yet. And then we'll just pass a pointer in here, and I don't know what that type that is, so just void pointer, who cares? I cast it anyway. So this is my do nothing struct. But it will help us to insert the tagging stuff into it. Let me see. So now I have pointer and static encoded. Load the current value of mmap-ed into head. What do I want in head here? I'm going to use that head to read as a pointer, but also to compare it again with mmap-ed. And this, of course, is the atomic, so this is the encoded one. So this also must be encoded. Excusez-moi. So it's actually the pointer tag value that we want. just load the whole atomic into local variable. So then can fix this comment, load that into that. That's what we do. Well, is this comment all the way up here outside of for loop and all? Use standard memory order acquire. I think it is totally belonging to this. Yep, so load the current value of mmap-ed tag into head tag. There we used standard memory order acquire, which was missing previously, to synchronize with the standard memory order release in deallocate. There's a release here. Because we write to this and then we write with release to mmap-ed. So then we load mmap-ed again with acquire and then load this value, then it will be synchronized. Whatever was written before writing mmap-ed will be also visible after reading that mmap-ed value. Now this next thing, here it is a pointer, but what I really need, of course, is the encoded version, because next is going to be written to mmap-ed. But I need the stuff to be split up as well, because we're going to change the tag at this point. So maybe I can say I call next the pointer, and I'm going to extract it. Well, actually mNext is just a pointer. That's just this thing. That's not encoded or anything. So what you need is to get the pointer part of the head tag, and then use that to get the mNext pointer, which is then this. But we don't write that. We have another thing. This must be the encoded type again. Or I didn't give it that name now. Maybe I should. Encoded type, or just head tag type? No, I don't know. Encoded type. I like encoded type. Or shall I just call it? Shall I just use this everywhere? Do that for now. Whatever this is what we want to write to the head tag. Head tag becomes an old head tag, and we want to go the new head tag. Return the previous value of mmap-ed that we just replace with next. Okay, let's say return the pointer corresponding to the previous value of mmap-ed tag that we just replaced with next head tag, and the previous value is stored in head tag pointer. But I read that already here, so the compiler is smart enough to do that. It's inline stuff, isn't it? Isn't it? Damn it. Yeah, it should be. I'm too paranoid. So if the head tag did not change and is still equal to that, which we read here. Yeah, no way, this is a pointer tag, damn it. So wait a minute, I'd create tags here. So we have to use the encoded value of that. Must be the atomic. It must be atomic value that we work on. So mmap-ed tag encoded parent exchange. The next head tag is already encoded. So that's gonna work. Head tag encoded, comparing changes weak head tag. No, that's also not working then. I'm still decoding it here, so this must be a pointer tag. But yeah, here it must be that ain't gonna work, is it? Compare exchange weak takes a reference to whatever the atomic wraps. So the uint pointer type. But yeah, I can get a reference by just taking encoded here as well on it. Should work. think it reads better if I tag haha and encode it here after it. At least then I have an encoded here as well, just like the thing before it and here. So compare and exchange the m-head tag encoded, as long as it's still equal to head tag encoded, with the next head tag encoded. Return the pointer corresponding to the previous value of m-head tag that we just replaced with next m-head tag. But yeah, encoded. It's not so much as the current. I mean, it's current in the sense that at that moment the head is pointing to it. But what it also is the beginning of the list, of the front of the list. What if I just call this front? I think that reads a little better. And it is a node. I'm going to call it front node. And the next node is unnecessarily vague. Let's call it just what it is, namely second node. So the front node, it's actually not, yeah, it's a front node pointer, but usually I leave pointer away. So it's kind of implied that it is just a pointer to the front node. Same thing here. So a node kind of means a node pointer in the variable name. And then I have I'm less happy now with the encoded. Just doesn't make things very much more clear here. Maybe I should make this a pointer tag. Isn't that what it is? And just only change that to, I'm gonna make it a pointer tag. So pointer tag, new head tag is something. Maybe the whole comment is unnecessary. We just return the front node. It's the whole idea of the allocate. Head tag was changed. This sorry. Yeah. Right, okay. I think it kind of more or less works-ish. If it compiles, it probably works. And this should be what? Well, this should be the encoded thing. So I had a static function here. I'm going to call pointer tag encoded. And then that must be the second node, right? We want to write the pointer to the second node to the head. No, we don't have a tag yet, but okay. So the new head is the second node. Okay, and then we can do this one. Deallocate. Okay, in the same terms, I would say this becomes the new front. We should call it new front node, as in the intention of it. And then here we have the next pointer becomes, we set the next pointer of the new front node. And that must become the well, first we have to load mmap-ed tag. Kind of the same there. Let's begin with that. So mnext must be the pointer that the head tag was pointing to. So this becomes a head tag dot pointer. Completely ignoring whatever the tag was. And then the new front node must be inserted in the list. So this again becomes new, sorry, mmap-ed tag dot encoded. Compare exchange week with the value that we expect which is head tag now. It's not this value, of course. It's just the last thing that we loaded. And okay, so we want to write anyway the new value. We want to write the new front node. To the head. The head must be pointing to that. So head becomes mhead tag becomes new front node. And that doesn't look good at all. So I need an encoded new front node. Oh boy. Let me first concentrate on this thing here. This must be the value that used to be the head tag. I'm pretty sure that it is this value, right? Which you write to M next. But if the compare exchange weak fails, then we must update the next pointer. It does not have a do while then now. It's more like do. Maybe we should just do a rewrite. Forget what I had. This must become head tag because it says head tag here, therefore this must be head tag. Exactly like here. And here we had a new head tag, and now we want to have new, also a new head tag. You know, it's just a new head. Damn it. New head tag encoded. And then therefore this must be a pointer tag, and this must also be a pointer tag. With the new value is depends on the no, wait a minute. Yeah, okay. We're going to deallocate this block. Yeah, so no matter how you look at it, that is going to be the new front node. And we have to initialize the next pointer of that thing to point to whatever the head is. But no, it must be set to whatever the head encodes as pointer, so what the head is pointing to, which is exactly this thing. And then we can insert it. It being this. Now the head tag itself is loaded with a quire in the beginning, and then every failure automatically updated here. This is again, this is a reference, passed by reference. So the only thing that needs to be updated in the loop is this thing, which I don't even have yet, the new head tag. What should that be? Well, that should be a head tag that encodes the pointer and well this pointer. So then not something that doesn't change. Unless I want to update the tag, of course. Hopefully it will show itself, as it were, by the time I add the tagging in. For now, I'm just going to add it here, because I don't think it needs to be in the loop. So I need a pointer tag called new header tag, which is pointer tag encoded with that node pointer. So the first two lines are just preparation. I cast the thing to the free node pointer, which we then use to which we then encode into a pointer tag without a tag. And it's called new head tag because we want m-head tag to become this thing. So that the head now then, of the head then points to new front node, aka points to the block that we just deallocated. And then I load the current head tag. And then whatever that head tag is, we set the next pointer of the new front node. This is not also constant, the new head tag. It's totally constant. For now it's constant anyway. Head tag is head tag encoder load, yeah. The front node next points to wherever the head is pointing currently. And then write the new head tag to a head tag. Pretty sure this is correct. Okay, this comment belongs to, well, let's put it here. No matter where you put it, it doesn't look very nice, I think. But yeah, this says the standard memory order release is used in the case of success and causes the above store to node M next. So that is now called new front node M next to be visible after a load acquire of mmap-ed in allocate that reads the value of this node. Okay, a load acquire. Well, must be that. Well, that reads the value of mmap tag. Why was I using the word node here? I think because I was writing it, so a lot of undos. Yeah, so you node is being the new value that we write to head. Can't say the do while is very readable like this. What about I put it after it? That looks better. Normally I don't use braces around single statement bodies, so it would get something like this. But after a do, I don't know. I'm not used to seeing that, so either way, it looks absolutely ugly. I think I'll leave it like this. Okay, then we have to fix the .cxx file. It also uses mmap-ed, otherwise it won't even compile. Try allocate more. This is put here because I didn't want to inline it. It locks a mutex and then returns true or false, checking if mmap-ed is now non-null. Well, after taking the mutex, it could already be non-null, so it's kind of the same test as the test that we did that caused us to come here. And I didn't decide yet what to do with that. And what is this? Add block. Yeah, that is just going to. It's doing an allocation. No, it's not doing an allocation. Sorry. Allocation is done in the lambda. So this is being. The lambda calls this and passes the newly allocated block, which has this block size, and the partition size apparently is I don't know, something. Apparently the block size exists of partitions. So the number of partitions given here. Block size must be multiple partitions size, at least 2 times. I don't know why, but okay. Character pointer, first pointer, block, it's the beginning of the block. The last pointer is then the end of the block. First plus number of partitions minus 1 times partition size. Oh, that's why partitions must be larger than 1. So the last block is unequal first block. Last pointer, I mean. Actor pointer node is the last PTR. We go from the back. Do next node is node. Node is next node minus partition side. Cause node to a free node, write the mNext pointer, being mNext in a loop until node, while node is unequal to first pointer. So we did this for the first pointer, then we're done. Still really don't get the assert though, because I might as well put a while at the top here. Then it will also work for partition equals 0, equals 1. Dot pointer first node reinterpret cast to free node on first pointer, same for the last one. Last node mNext becomes mHead. I think it's kind of nonsense. Oh, no, it's not. It's not really nonsense. We did lock a mutex, but the mutex is not locked for both allocate and deallocate. So at mHead can still change in that it can be. Yeah, it can totally change. Someone could free something and then the new allocation could take that again, even before we have new blocks. So this part very much looks like a deallocation. Can I not reuse that? Otherwise I have to redo everything again. And that thing was 2 lines, which I just duplicated here, but now it's considerably larger. So what deallocate is doing, it is setting the next pointer off. Oh, okay, that won't work. Let's just copy the whole thing. See, this is now last node. Let's call this last node then. Apparently you can use static cost. The new head tag must become the first node, I think. Yep, I think that's it. Only thing left to do is look at that null value. So I'm gonna have the definitely loading the tag here, and that then is definitely not null pointer, but maybe null. Instead of null, let's use end of list, because I just can't decide what the value is, but I should be able to just compare it, right? So either it's null or maybe something else, or I don't know, but preferably we can just do this compare and without having to do other stuff. And then the same kind of compare should lead us to get here in the first place. Try allocate more. That would be this test here. So here this is also testing for null. Now head is again a head tag. Okay, but. What in the actual... Never trust an AI. Yeah, I gotta remember this now. You cannot just cast between an integer and a pointer. Not even with reinterpret cast. So this won't compile. Ask ChatGPT and get a wrong answer. How do we solve this? I think that you have to use bitcast. Is that not the answer these days? Cast an int int pointer type. To pointer or void pointer pointer. That's an uint pointer type. And they cast it to a pointer. I'm so confused. Okay, apparently I was wrong. You can cast it with the reinterpret cast. GCC 15.2. Well, there's a 0.1, so totally going to work, should work. Nah, I read the arrow wrong or something then. Oh, it's a bloody atomic. Yeah. That's why it doesn't work. But still, yeah. Well, conversion from, so look what that is. No. I don't know. Let's get rid of the atomic anyway, because it might be slightly in the way then. That is something, man. I don't want all my local variables to be atomic. It's just nonsense. I think the whole thing should not be atomic in the first place, except for the member function, mmap tag itself. I have quite a few. I have some pointer tag locals, right? I mean, do I really need them? Okay, let's have a look. I have two here. That's it, but it's .cxx. Two here, two here. 6 in total. Yeah, these arguments don't have to be atomic. Can't even be atomic, I imagine. Tick encoded, 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 encoded. Only accessing encoded directly. So let's change the type of mmap tag then. I mean, here as well, right? Encoded, 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 yep. So I'm going to change the type of mmap-ed tag to a non-pointer tag type, namely just the encoder type, and then make it atomic, which means you can remove this, and then it still works. Here's same thing here. Lost the word encoded now, but it says head tag, so it sounds very encoded to me. Still talks about conversion. Now we try to go to pointer tag. Okay, maybe that makes sense. Do I need a constructor for that? Here's the error, actually. Conversion from atomic again to a non-scalar type pointer tag requested. Okay, no idea what it's talking about. Let's just look at the code. Yeah, missing constructor. I'm so not going to add a constructor. Just to use an initialize list. That should work. Encoded also returns a standard UINT pointer. That's kind of silly. I was going to clean it up afterwards, but maybe I should do that right now. As in, I am going to add in a constructor. First constructor, constructor directly from second node, which is a free node pointer. Same thing here. I could just do this directly, but I want to know where it is. So, I mean, if I put the reinterpret cost directly here and delete my encoded static, then it won't be as easy to find back where the encoding happens. And we need to know that because I'm going to change it, right? Add the tagging and stuff. Okay, they have a new I can't think of the word. Something like it's a hype among compilers to now print a lot of empty lines. No, the word I was looking after was union, yeah. But so, I mean, the compilers form a union and then they do what they like, so that's what the idea, but the joke is still very far. I used to be able to create a joke, so real time while talking. You know, I don't get further than knowing that I was looking for a keyword which I couldn't find. And even if I find the keyword, there is still no joke. And again, invalid conversion from blah blah blah. Yeah, okay, whatever. Just look at the code. It never ends, does it? Oh, this is another constructor. Yeah, well, it used to work to initialize the list, but not if you add a constructor. Well, might as well go the whole way. How many times do I use this? Right, and probably every time with acquire. It's a construction from something loaded from mtag. mhead tag, I meant, obviously. Load acquire, yeah, same thing. Which doesn't make much sense now I think about it. Get the acquire here, that's a good one. Need acquire here as well. What is acquire doing here in my deallocate? Should be relaxed. Relax, man. Yeah, it's the same thing as the failure memory mode of this thing, which is because we only pass one of them. This minus the release, so it's only a release. Minus a release is relaxed. So yeah, if it fails, it's loaded relaxed. Might as well start with loading it relaxed. Otherwise, that would be wrong as well, and it isn't. I'm sure of that. Okay, so that out of the way, let's construct it directly from the mmap-ed tag. No, I can't, because now here it's relaxed and there it is acquire. I could do that, but I could, I don't know, I could heavily confused again. The load is just returning my encoded type, isn't it? Well, why is the pointer tag not working with that? Oh, I just added the free node constructor. Yeah, of course, not just nonsense. Okay, it's constructed from whatever load returns, and here again. And then we have here another one. And that looks like the same thing. It should be relaxed. Okay, and then we need a new constructor. Pointer tag. Nope. No return. Let's fix that first. Oh, I just commented it out. That's my MemoryMappedPool, yeah. Work in progress. Well, I guess the next error is this one. Is end of list is private. I'm using it in the base class, okay. Derived class, I mean. Well, then let's make it protected. Can we not combine that here? Everything is protected. Oh, and suddenly, I mean, this used to work, I'm sure. But suddenly it is no longer working. You cannot cast from character pointer to another pointer, apparently. Why not? Why? Okay, now I also worked very hard on a test, so you can just test it. How amazing is that? Yeah, this is my test. Completely reworked it. Does lots of stuff. Okay, that's not good. Oh, it actually finished. Thought it was not good. No, these times look more or less the same. Yeah, but maybe, yeah, 17 gigabytes, so I think those few seconds are acceptable. So I'm pretty convinced that it still works then, and despite what I just did. Because 1, it compiles, and 2, this still runs. No, it just works. Yeah, I didn't really do that much, really. I mean, it's the same, it's doing the same thing, more or less. Just renamed mmap-ed to mmap tag. That's the only thing I did. Okay, introduced the pointer tag, which is just a wrapper around something, which is the something being an in pointer type, which is exactly the same size as a pointer, and therefore we need a few casts. But hey, for the rest, nothing changed. So here I did last node next becomes mmap-ed, and here we have last node next becomes head tag pointer. Which is mmap-ed, so. And then upon failure we update head tag. That's why we have to read from head tag again. While here we wrote directly an update to mnext. So order a core. Yeah, lots of variable names being renamed, but okay, let's make it a little bit more readable, because especially having to access encoded all the time is maybe not that super nice. So I'm calling compare exchanged week on mmap-ed tag. Oh, yeah, mmap-ed tag is no longer an object. Yeah, maybe I can leave it like this then. Right, let's add tagging. It should be possible to do that now all in one place. That is encoded. Wherever I use encoded, it should include the tagging, because that is the compare exchange week thing. It should only be used here. So yeah, I really wanted to make this a member function. Still do that, I guess, but what did I just say? Wherever I use encoded. Okay, and yeah, it should be encoded. That's what I said, I think. And well, that then should also be true for end of list. Suppose you can make end of list and some type, and then remove the encoded here. Just add an unequal boolean for the pointer tag. I think you can remove it anyway. I would prefer if this would not compile though. And then I have to fix it. Hmm. Yeah, it's not encoded here. Well, it is here, but yay, it does not compile. So compare with uint is to be added. I can make this just a member function of the current object, okay, of simple segregated storage base. I'm not sure if that makes things really more readable and stuff, but I feel like I should really get rid of all the encoded. Although no, getting rid of it is not enough. I mean, if I move it to another member function, I want to access encoded exclusively inside the pointer tag. So that would mean that this thing must become a member function of pointer tag, which would really help if head tag would be a pointer tag. But yeah, it can't be. Unless it can, and I can just wrap it in a standard atomic, which I absolutely don't believe. No, I don't believe that. Yeah, and on the other hand, we would get rid of several of them. I mean, there would be only two encoders left in a private function instead of 6 in public functions. So how would that look like then? Like that, I guess. I'm gonna do the M here. Compare and swap head tag. Head tag, new head tag, and whatever order. And that should then result in this. So void, no bool. Okay, what the hell is the type of this? Is that memory owner? Right. So now the pointer is going to occupy only a few bits. A few bits. Well, a few bits less. So the most significant bits, basically. How many? How many bits? I don't know. That depends on. Partition size, isn't it? So what if I make the partition size fixed? So I have, wherever I'm using this, I'm calling add block. Which is in the memory page pool. And also here. That doesn't look like a constant, really. Oh, it totally looks like constant now, suddenly. Okay, still memory page pool has it as a dynamic parameter. Node memory source changes it later on. Yeah, you have to call init afterwards. An unknown with fixed size, so that is not known at compile time. Yeah, okay, so, yeah. Can't do that then. I was wondering, I mean, I could say, well, I just add 3 bits, or how many bits do we have? 2, 4, 8, yeah, 3 bits. Because my pointers are definitely going to be aligned per 8 bytes. Can even enforce that, as it were. And then only use 3 bytes, even if you have more bytes available. No, let me look at ChatGPT's code for some inspiration there. It's just 2 bits. I guess this code is copyable. Is this even working? This is an int. Shifted by 2 is 4, minus 1 is 3. Still an int. Tilde in front of it is, if you ask me, still an int. So something with a lot of ones, but 32-bit wide. Unsigned. Probably, yeah. And then we assign that to the pointer mask and all hell breaks loose, because it doesn't have the high bit set at all. This is not working at all. Can I use anything? I don't want to use 64 bits. Although I think that is that not. I don't know which is faster. I think the fast int here is 32 bits. I'm not sure even. Yeah, it doesn't really matter. I mean, it's only 2 bits. We use only the lower 2 bits of the tag. Okay, is this encoding it correctly? Let's turn end of list into encoded something. Which is non-null. That means that encoded must now be a const expression. So static up front here as well for the function. Yeah, maybe. Okay, what is going wrong now? Because in my head is set to end of list, so that would work, but then we allocate more stuff. It's definitely not going to work. Okay, I want to see it crash. At least then we know that it. Oh. We know that the test suite is doing something. course definition is complete. You're kidding me, right? That makes no sense whatsoever. What do you mean definition is not complete at this point? Because it is inside this class, and this class definition is not finished yet, and therefore I cannot even call anything from pointer tag. That is ridiculous. Yeah, it's 8 o'clock. I'm going to eat. Yeah, eating time. Well, yeah.